And hello everyone, welcome to your Lua crash course. So this course will contain everything about Lua. We'll learn Lua, and then later on we'll learn a little bit of Love 2D, and then we'll build a few games with Lua. But let's not get ahead of ourselves. What exactly is Lua? Lua is a high-level procedural programming language designed in 1993, primarily to be embedded into other applications. If most of this flew over your head, it's perfectly fine. Most things you'll have to take in here is that Lua is a procedural programming language, meaning that things like object orientation doesn't really exist in Lua, but you can simulate it. These days, it is mainly used in games, so you'll usually see it being used with Love 2D or Roblox, or it will be used with games built in C or C++ as a little bit of extra used on the side. Now, where exactly was Lua used? Well, it was used in Adobe Photoshop Lightroom, Apache the HTTP server, the awesome window manager, Roblox, Angry Birds, The Sims 2, Mafia 2, World of Warcraft, and Fable 3. As you can see, a lot of these are games because Lua is very popular to be used with games because of how easy it is to embed Lua in your game. Well, what text editor should you use if you want to code along? Well, it can be absolutely anything, from a Notepad all the way down to IntelliJ IDEA. I will be using VS Code during this whole course, mainly because that is what I have grown to love and learn. But if you have no experience in any of these, I would recommend using Notepad, but if you want something a bit more powerful, then definitely go Sublime Text. So just go to the Lua website, so lua.org. Then here you have a little download option. Click on that. Then you want to just ignore all of this because compiling on Windows, gross, who wants to do that? And this is a Linux only thing if I'm correct. So we can actually just go to here. If you don't have the time or inclination to compile Lua yourself, like any normal Windows user, get a binary or try the live demo. We want to get the binary. Binary is just basically the executable. Now don't be fooled by all of this. You don't download it from here. You go to this download page right here. They make it a massive pain to actually get what you want. It's very interesting. Then here you have a bunch of options to choose from. I would like to go with 5.3.6 because 5.4.2 has a lot of changes and stuff that just sucks. So here we have a bunch of things we can choose from. This is Linux. This is Windows 32-bit. Windows 64-bit. If you're on Windows, you probably have 64-bit. And take note, this will also work on Windows 11. Just because I'm using Windows 10 doesn't mean it won't work on Windows 11. And then we have Mac, which I seem to not be able to download. And then we have more Linux. Or that's the source. This is Linux. Now we want the 64-bit zip file. So we click that, it will start downloading our files. You just say save file. And I believe it's done. We can now open up our file manager and we can go to downloads. And you see we have a Lua 5.3.6. We can right click and extract the file. If you don't have this option, I recommend you go install WinRAR or some sort of file extracting software. I like using WinRAR because it just works. I'm going to extract to Lua 5.3.6. But if you just said extract here, it would have been perfectly fine. Now in here we have a bunch of options. Or not a bunch of options, this is just the executables. This is the most important file here. This allows us to actually run our Lua code, which we'll do in a second. Now what we need to do is we can go back here and we can rename this. You can rename it to anything you want, but I'll just call it Lua. Because that's simple, you know that's Lua. Now I'm going to copy this, so you can right click and we can say copy. And I'm going to go to my local C drive. Now you can just paste it in here if you want, but I do prefer going to Program Files, right there, and then just saying paste, because it's a program, so we want to paste it here. There we go. Now next thing we can do is we can open up the command prompt. So you can click here, search command prompt, and it actually, why did I go to this page? Anyways, once you search command prompt, you should see this. Now first try to type Lua. If you don't get anything, that's perfectly fine. Try to type Lua 5.3. Doesn't work. Okay, if you do get this, then that means it has not yet been added to path. One way to fix this is by rebooting. Another way to fix this is by going to settings, which can I search here? I can, okay. Going to settings, and it's searching here environment variables. So here, edit the system environment variables. And in here, you can just say environment variables down here. Then you don't have to worry about this too much. You can go down here to path. You can say edit. And these are the locations where all the environment variables is. As you can see, my program files x86 is here, but not my normal program files. Or at least some of these x86s are here. So what I'm going to do is I'm going to say new, and I'm going to browse, because the thing is, it's a very difficult way to get there. So I'm going to just browse to where it is. And here, program files, we saved it in there. And there's Lua. Now if we say OK, as you can see, it added it here for us. So it added it to the program files, now, or the environment variables. Now if we were to say OK, I just need to put a folder there because it's going to scan the folder. You don't have to worry about the executables. You say OK, and you close that. Then now also, if you do want to, you could always rename this to Lua and just remove the 5.3. I don't know if that will still work, but I'm pretty sure it will. You then have to exit out of the command prompt and just open it up again. Okay, please open here. And to look like a hacker, you can say color 02. Cool, now that we look like a hacker, we can clear the terminal, or CLS, and we can say Lua 5.3. This will allow you to code Lua. If you see this, you did it correctly. Also, if you didn't download Lua 5.3, you will have a different number here, depending on the version you downloaded it. And that just executes the program. Now we can say print test to make sure this works. If it works, then you're good to go. Next up, you probably want to actually try and run a file in Lua, or a Lua file itself. I'm going to create a new folder. I'm going to call it Lua. For my Lua programs. Here I'm going to say new text document, and make sure you can see this .txt there. We want to change that. So we're going to say main.lua and remove that .txt if it was there, and just say yes, and you should see this. You can then edit it with Notepad if they give you the option to do it. So let's open it with, and let's see here, more apps, Notepad. There we go. And yeah, we didn't need to always open it up with that. Then here we can of course just say print I am cool. Save this file by clicking file and save, or just Control S. And you can close Notepad. And now here you can just shift right click and you can say open PowerShell window here. There's multiple ways to do this, but this is usually the easiest. Then you'll see this. You can then just say Lua 5.3. And in the file, so there, right there, main.lua, we can then say main.lua. There you go, I am cool. If, however, this did not work, then you can just open up your command prompt again, bring it over here, whoa. And now we need to navigate to this folder. One way you can do this is you can just right click here and copy address. Now you can just say CD for change directory, and right click. If you right click, then it will paste it here. Press enter, and now you're inside of this folder. Now you can say Lua 5.3 and main.lua. There you go, I am cool. First, you open up VS Code. This is a VS Code specific tutorial, so you search VS Code. If you don't have it installed, you do need to go and download it. Okay, then once you have your Visual Studio Code open, you want to go to File and then Open Folder, not Open File, but Open Folder. Once you say that, you can go to your folder where your Lua program is in, so that main.lua file or whatever you call that file. And here we go. I have a main.lua file which just says print I am cool. That's all it does. It's just this file right here. And I can show you that this file exists by going to my documents and to that folder I just opened. There we go, main.lua. Cool. Now that you have this here, you can just go to Terminal, New Terminal, and here we have a terminal. If you have Lua already installed, you can just say Lua 5 free and then main.lua. I am cool. As easy as that, you have just executed your Lua code. I'm going to open up my file manager and I'm going to go to Documents. I have a special folder called Trash where I put all of the things that once I format my PC, I don't care about it. You will probably have a code folder similar to what I have here where I put all of my other code. But for me, I'm going to put it in Trash. I'm going to create a new folder and call it Lua. In here, I want to create a new file called main.lua. If you're on Windows, make sure that this actually ends in main.lua and not main.lua.txt. Windows will oftentimes append that extension to the file name, which you do not want. Once you have done this, you can open up your code editor in this folder. Since I use VS Code, I'll quickly open it up here. Here we go. Now everything you see here is what will appear here. So this main.lua, that is here. If this right here says main.lua.txt, then Windows did you in and they try to add a .txt extension at the end. You can just go here and then rename it and remove that .txt. I'm going to close this file manager here because I don't need it open anymore. Alright. Now first off, I would like to resize everything just so everyone can see. Great. To run my Lua code, I will use this terminal right here. But take note that this terminal is the exact same terminal as this terminal right here. The two are exactly the same. The only difference is this terminal is inside of VS Code, while this terminal is not inside of VS Code. That's the only difference. They both run the same thing. If you're on Windows or Mac, you don't have to open up a terminal on the side. You can just go Terminal, New Terminal, and you'll have a terminal to use. Alright, now that we have that out of the way, I'm just going to get my setup ready. And here we go. And this is why I like having this terminal here. It just looks so much neater and we have a lot more space to work with. Next up, I'm going to close my file manager because I don't need to see this Lua file because I'm already in it. So let's start with the basics. Make sure you have Lua installed by going lua-version. And actually, if you get this, then you know Lua is installed. But if you go lua-v, then you should also see this. If you just type normal Lua, then you'll be able to do something like print any type of text, and you should see this. To exit, you can press Ctrl and D, Ctrl and Z, or Ctrl and C. Alright, so I have Lua installed, as you could see there. So let's get started. First, I would like to tell you about comments in Lua. Oftentimes, if you're following along, you want to leave yourself a little note to explain what is going on. And this can be a comment. A comment is not read by the computer. So when you run this Lua code, a comment will be skipped. So if we go -- and anything that starts with 2 dashes is considered a comment. So this is a comment. This is also a comment. You're not limited to the amount of comments you want or have. You can just do as many as you want. But that is also a single line comment. It basically means that once I go to the next line, I'm typing regular code. You'll notice that here we have green text, and here the text is not green. That is because this text right here is not a comment. So this is a single line comment. Every time you want to add one, you'll have to add the 2 dashes to say it's the next line. You also have a multi-line comment. If you plan on having a comment that's a few lines long, such as a description of something, then you can say dash dash and in 2 brackets like this. This right here is a multi-line comment. And then make sure there's no space between your dashes and your brackets here. There we go. Now this can range multiple lines. So multi-line comment. It is amazing because now everything that's between these is part of the comment, meaning if you put any code in here, it will not execute. Same here, if I put any code in here, it will not execute. This one is just one line, whilst this one can span multiple lines. Alright, next up, let me actually show you how to print something to the screen. To print something to the screen, it's actually simple. You just use the print command and I will print something to the screen. Hello world. So print, and then in brackets we have quotation marks and then a piece of text we want to print to the screen. The quotation marks and the brackets are both important here, so do not leave either of those out. If you save your file and you run your file with lua main.lua, and take note, I'm in the same folder as this file. I am in this folder. If I say terminal, new terminal, you'll notice it's in document trash lua. And that is where I currently am. I know there's a lua file in here because if I say dir, I can see a main.lua. Alright. If you say lua and then your file name, you'll get hello world, because that's what we're printing out here. You can have as many print statements as you want. Yet again, you're not limited to anything. So let's try hello Jeff. And here we'll now have a hello Jeff. And here's an example of where you could add comments. Here we could say print to the screen. And here we can say will print hello world. You'll notice my single line comment doesn't have to be on its own line. It can be after a command, for example, print. So here we're saying print and then we're putting a comment after it. This comment will not be read. If we were to remove those, the comment will be read and we will get an error, such as this. As you can see here, it doesn't know what that is. So if we make this, then it can continue. Take note that comments will also stop code from executing. So if I were to make this code a comment, it will not be read. So when we run this, it's just going to say hello world and no longer hello Jeff, because hello Jeff is now a comment. To split your print up into multiple words, or to add multiple things to your print statement, we can add a comma. I am cool. This comma here will add these two together. However, take note that this comma will add a tab between the two. So when we run this, we'll get hello world and then a massive tab, I am cool. If you want to add these two together without getting a tab, then you could use 2 dots. And these 2 dots means concatenate. Concatenate just means add 2 pieces of text together. If we save this, we get one long piece of text. If we add a space here, then there will be a space between the 2 pieces of text. What exactly is a data type? Well, a data type is very easy to understand. For example, when I say 5, what is 5? 5 is a number or an integer. This is a data type. 5 is the data type of number. And that is how data types works. They're very simple. So we have nil. Nil means nothing, empty, null, undefined. So if something is nil, it doesn't exist or it's empty. We then have a number, which would be something like 1, 2, negative 99, 9.87. These are all numbers. We then have string, and string is just a fancy word for text. So anything in double quotes or single quotes. These are all text. We then have Boolean. This is yes or no, also known as true or false. So true or false. If something is true, you can think of it as yes. If something is false, you can think of it as no. So when someone says, is it true that you were 5? Well, that would be yes, because it is true that you were 5. Or if when you make a statement, and it can be either true or false. I have been to jail. That is false. I have never been to jail. So nope, that is not true. And then you have tables. Tables is the equivalent of arrays in Lua, or lists, if you're coming from Python. Tables are out of the scope of this video, so we'll be leaving them for a different video on their own. Okay, so those are data types. They're the basic ones you'll mostly be working with if you're using Lua. Now, let's get an example of a variable. A variable is something that can contain something else. It's giving a name to something so you can reuse it later. For example, local name. This is how you create a variable, by specifying local and then the variable name. This can be anything from x to name to example, like that. One way I like to teach is by using a little bit of math. For example, we have x. Now, of course, if we were to print x here, and this will just display what is inside of this variable, we'll get nil. We can also set x equal to nil, and this will be nil. You can also set x on a different line than when you created it. So here's x, and we can do that. That also works. We'll still get nil though. So let's say x is 3. Now, if you remember the basics of algebra, you can usually say something like x plus 8 is equal to 11. Now, you remember maybe in high school where you had to convert this to figure out what x is. But in this scenario, we are actually getting x. We know what x is. We are providing x. So we know we'll get 11 here. So we run this, we get 11. So x here is just a placeholder for this number 3 here. So if we do this, we'll get the same output. But this time we're just storing it in x, because now we can reuse it wherever we want. So if we run it, we'll get 11. If we change x here to, let's say, 8, then x will be changed everywhere to that 8. And we'll get to showing you more examples in a second. But you do get two types of variables. You get the local scope variable, which means it is not allowed to be used outside of this file. And when we get to it, outside functions. That is a local variable. It's not allowed to be used outside of its scope. So in this scenario, it's scoped to this file. If we create another file, we cannot use this variable from that file. But then you get your global scope variable, which could be something like global variable. And this could be 10. This global variable, as you can see, it does not start with local. It is because it is globally allowed to be used. So this global variable is allowed to be used outside of this file. So if we create another Lua file and we try to use this variable, which we'll get to in a future tutorial, we are able to use this variable. However, it is definitely good practice to go _g dot whenever you create a global variable. This is just to specify this is a global variable. It's not necessary to have this, it is completely optional. But it is kind of recommended to have an _g just to give that extra specification we're talking about a global scope variable. Now, if a lot of this is flying over your head, don't get too concerned. We'll be practicing this a bit in future tutorials as well. Now let's look a little bit more at variables, just variables in general. We can have a floating point variable, and a floating point variable is something like 3.1415, whatnot. We can have an integer type variable. Both of these are considered numbers, and this would be a free. We can have strings, so single or double quotes, and in any piece of text. This can include these dashes that are usually used for comments. And we can also do Boolean, so true or false. Booleans are a little bit out of the scope of this video, so we'll definitely get back to them in the future. As for strings, as I said, you can either do single quotes or you can do double quotes, but you can also do 2 brackets, and this will allow for multi-line strings. Take note, these strings are taken up very literal, so if we were to print F here, then we'll get a very literal representation of what we had. So if you don't want it to have a tab and a new line, you might want to just do this. And now you'll notice if we were to run this, it will look completely different. And the last thing I want to show you about variables before we move on to an example of them is how you can assign multiple variables at a time. For example, let's go local 1, 2, 3. Alright, so we have 3 variables here, separated by commas. Now we can just go 1, 2, 3. So now 1 is assigned to this 1 here. 2 is assigned to this 2 here. And 3 is assigned to this false here. So they're following the same pattern. And this is how I can assign multiple variables at the same time. Now let's use an example where we actually use a variable. For example, let's go here and say local name is equal to Steve. Then print hello, my name is, and remember to concatenate, we can use 2 dots and then whatever we want to add. In this case, we can say name. We can say name because name is a placeholder for this Steve here. So saying this is exactly the same as saying this. Let's go here. I have a cool name and then Steve. And here we have a little bit of an example. If we were to run this, we'll get hello, my name is Steve, which is here specified as name. Then here I have a cool name, comma, Steve. I have a cool name, comma, and then the name variable. If you wanted to, you could do this. Well, this is perfectly fine as well. It will give you the same results. But think of it this way. Let's say this was a piece of text that was probably like 100,000 lines of code, right? And now you want to change the name from Steve to Mike. Now you have to go Mike, and you'll have to change it on multiple places. So first Mike, and then you have to go Mike, and you have to do this 100,000 times. Immediately you can see where the benefit of using a variable would be better. Because if we use a variable like this, then if we change it at one place to Mike, Muk can also work, then it will change everywhere. And take note, once you have assigned a variable, you can reassign it. So if I go here and say name is equal to Steve, then now name will be equal to Steve. So it's first Mike or Muk and then Steve. So take note, you can reassign a variable if you ever wanted to. in this tutorial, we'll be talking about strings, aka text, anything in single or double quotes. So as we've learned from previous tutorial, local x is equal to str. This is a string. This will be taken as a piece of text and we can use it. The same with single quotes, str. This is also a string. This will also be taken up as a string. And then last but not least, these double brackets. These are kind of like literal strings. Whatever you put in here will really be displayed. So if I put a tab here, this tab will be displayed. If I were to print this and run it, as you can see, it literally takes those tabs and new lines. So those are the three ways you'd usually be making a string. Let's continue to actually using a string. So let's say we have a piece of text here. Hello world. This is just a string. Normal string, doesn't do anything. To get the length of the string, we can put a hashtag here. And a hashtag in Lua basically means return the length of something. So if we go here, we'll get 11 because there's 11 characters in here. We could also put the hashtag here. This will also get us the length of the string. Because remember, x here is just a placeholder for this string here. So this right here, that x, is the same as me doing this. And of course, for concatenation, you can just say 2 dots and then what you want to add. Let's say an exclamation mark, and now there will be an exclamation mark. Let's say you maybe have a number, so local num is equal to 20, and you want to convert this number into a string, a piece of text, because there is a difference between numbers and strings. Well, to do that, it's fairly simple. Let's say local str is equal to toString, and this will convert this num to a string. Now if we print num and then also string, you won't really see any difference. Both of them will say 20. But if we print out the type of these, and we can do that by saying type, and then just like that. So now type and then the variable, and that will give you the type of this variable. If we were to run this, we'll get number and then string. So you'll see both of them have different types because one is now a string while the other is a number. Now with strings, you have the cool thing of escape characters. So here with print, we have a bunch of escape characters we can use. For example, hello, \n. \n means a new line, so go to the next line. World. \t, this means give it a tab, the same as saying a comma here and then putting something new there, but this is just in one string. I am, and then \v, take note, \v may not work on Windows. I have heard some comments say that when they use \v, they get like a symbol instead of a vertical tab. A vertical tab is just when you tab down instead of tab left. And I'll show you that in a second. But \v gives you a vertical tab. Almost 19. 2 backslashes will give you a backslash. And a backslash escapes a character. So you'll need 2 backslashes to get 1 backslash. And then here, we can say 20. So it's kind of 19/20. And now let's say I wanted to put double quotes in this string. There are 2 ways we can go about this. The first way is I can replace these double quotes with single quotes. And now I can use double quotes. Yours. This works perfectly fine. But sometimes that you cannot do that. Sometimes that will not solve your problem. In those cases, if you try and do this, you'll actually get an error. So to keep these these double quotes inside of your string, we can use a backslash, and these will escape the double quotes. And the same will be done for single quotes. So if you backslash a single quote, it will also be escaped. And these are just a few of them. There are a ton of these escape characters, but I'm not going to go through every single one of them. If we were to print this, we get hello, new line because \n, world, then a tab, not a space. This is a space. This is a tab. Then we get a tab because \t, I am, and then a vertical tab. This might not work on Windows, but it just basically tabs down instead of left to right. Almost 19 \20 years. And in our quotes. Take note, forward slashes are not the same as backslashes, so backslashes will need 2, while a forward slash only needs 1. Next up, let's say we have a local string, and this string just contains hello world with an exclamation mark. Now if you print it, we'll get hello world. But there are a few things we can do with this string which is pretty cool. First off, we can say print, and then we can go string, and this will use the string functions we have inside of Lua. There's a lot. I'm not going to cover all of them, but I will be covering the ones you might like to use the most. Dot lower, and this will convert the string to lowercase. And just say str here. You can do the same, and then for upper, so uppercase, and then you also have one for ling, and this will get the length of a string. It's the same as if you were to say, instead of string.ling, you were to just go hashtag. Hashtag you can see as a shortened version of this. This will return the length of the string, this will convert the string to uppercase, and this will convert the string to lowercase. Let's see what we get. So we get our normal hello world, then a hello world that's just lowercase, a hello world in all caps, and then the length of this string. So let's start with mathematical operators. There's a lot of them. For example, 5 plus 5. We all know what this does. This will add 2 numbers together. I'm going to add a few here because we have quite a lot. We then have minus, which will of course subtract. And this could go into the negative values. You're not limited to just positive numbers. We have times, which is represented by an asterisk and not an actual X. So an asterisk. We have divide, which is a forward slash, not a backward slash, but a forward slash. And let's say we give 19 divided by 5. You have to the power of, so this would be 5 to the power of 2. And then we have modulo. And I'll explain this one after I've explained the rest. So let's go 17. Right, if we run this, here we go. So we start with 10 because 5 plus 5 it's 10. 5 minus 15 will give you negative 10. 5 times 5 is 25. 19 divided by 5, that will give you 3.8. Then 5 to the power of 2 will give you 25. And then 17 modulo 5 will give you 2. Now, all of them are pretty simple to understand. We have all learned these in school, except for modulo. You did learn this in school, just not quite the same. In a very basic sense, modulo is what is left over. Not literally, but it is what is left over. For example, if I say 17 divided by 5, well, that will be 5, then 10, then 15, right? So if we were to say 17 minus 15, we'll get 2. Because 2 is what's left over if you were to divide these two. To give an example, let's just go here and say 17 divided by 5. One gives us 3.4 and the other gives us 2. Because 17 divided by 5 will give us how many times 17 can be divided by 5. 17 modulo 5 does the opposite. It gives us how much is left over once the 2 has been divided. So not this 0.4 here, but the actual value. Because if 5, 10, 15, and then 20. 20 cannot go into 17, so we'll have to stick with 15 because that's the lowest value we can get if we were to do this. And of course, 15 minus 17, or actually other way around, of course, 17 minus 15 will give us 2. And this is the remainder. That's what's left over. So it's almost the opposite of division. You don't have to worry too much about it. We will be using this a little bit more in the future, but you can get more used to it as time goes on. One thing I remember that people in my class always had trouble with was the order of execution in math. And order of execution can be a difficult topic because you might not remember what order what should be executed in. For example, 5 plus 2 times 10. Now, I'm relatively okay with math, so I would immediately notice that this 2 times 10, that should be done first. And then after this has been done, we'll get this 5 plus 2. But not everyone will notice this immediately because that is just normal. Not everyone is made the same. So some may see this and think, oh, it's 5 plus 2, that's 7, 7 times 10, that will give you 70. But in actuality, it will give you 25. Because 2 times 10, that's 20. And in 20 plus 5 is 25. Now, if you're one of those that can't always remember in which order this happens, or if you just want to change the order in which this happens, then I have a solution for you. Brackets. Brackets is what we can use to specify when what should be executed. So here we could say it's first 5 plus 2, then we times it by 10. Because brackets will take priority over everything else and it will be done first. Now we will get 70. Because now it's first doing this, then it will add this. And it's perfectly fine to do it over something that is going to do first. I sometimes do this as well to make myself remember this is what will happen first. As you can see, now we'll get 25. And you can of course add more things. So now if we go times 7, then we'll first execute this. Then it will execute this. And then it will execute this. But if you want to change that, you could do this. Now it will first do this right here. Then it will do this right here. And then it will do this. So the order of execution is up to you. You can change it depending on what you want. And now I can look at a few things inside of the math library. Print math.pi. This will print out the value of pi. Very useful in some cases of 3.14159.265 and so on. We have math.min, which will give you the minimum value of something. So let's say 10, 5, 189. The minimum value here would be 5. That's the lowest value of all of the values passed in. If we run that, we'll get 5. If we change this to negative 10, for example, then now we'll get negative 10 because that's the lowest value. You can also do max. Max will do the opposite and return the largest value. So now we'll get 100. Then you have rounding, which can be very useful. So you have math.ceil, and this will round up. So 20.9, and we actually give a few here, 20.1. So these two both will go up. They will round upwards. If we run this, we'll get 21. They will not round down. Ceil is, in a sense, the ceiling. The ceiling is always above you. So if you look up, then that's what it will round. It will round towards the ceiling, upwards. Then you have the floor. The floor will do the opposite because the floor is below you. It's down, so it will round down. That will give us 20. So this is a way to force rounding to a specific point where it's either down or up. And last but not least, let's talk about random numbers. Print math.random. Simple as that, you'll get a random number. Run it, run it, run it. That's cool. You can do multiple. So that's pretty neat. But sometimes you want your randomness to be more random. To do that, you can pass in a seed. So math.random seed, and we can pass in os.time, and this will ensure that our random values we get here is always random. They will never be repeated continuously. So now if we run this, we'll get more random values. We did get a few that repeat here, but that's just sometimes if you roll to raw random, you'll get the same thing. And this only updates once every second. You can specify up until where it should go. So if we say 10 here, then it will random to 10. So 2, 10, 4, 2, 7, 7, few sevens there. So we'll continuously random towards 1 and 10. So between those two. You can specify another value here, for example 50. Now it will be between 10 and 50. So it will not go underneath 10, and it will not go higher than 50. So your program can make decisions. That is absolutely epic. You can make your program make these decisions by using an if statement, like asking a question. If something is true, then do something else. So in this case, if true, take note that's a boolean, then, and here we can just print, this was true. So one of the most basic data types is used with one of the most complex type of statements. That is pretty epic. If we run this, this was true. Now the cool thing here is, this code will only run while this here is true. If I make this false, then this code will no longer be ran. So it skips it. This makes everything way more powerful. For example, let's say local x is equal to 2. And if x, and then this is a cool symbol, is more than, and let's say 5, then print x is more than 5. Run it, and oh, x is not more than 5. So this will not run. But if we were to say x is 9, because x is more than 5, we'll get something out of it. We also have the opposite symbol, so less than. So we have more than and less than, where you can figure out more than, we'll try and get the one that's the biggest. So if this one is bigger than this one, it's because it will try to eat the largest one. So this is a mouth, and it's trying to eat the largest one. If this is bigger than this, then it will be true. This is smaller than, because now we'll try and eat this one and hope that this one is bigger. So this will see if x is less than 5. Run it, it skips the code, but if we were to make x 2 again, then we'll get x is more. That should actually be less than 5. But you still get the point. There's a lot more comparison operators, which I'll get a little bit more into, but not every one of them. So we have the and, or, not, and I'll get into a lot of these. More than, less than, more or equal, less or equal, not equal. Yeah. Take note, in other languages you'd usually have a not equal like this. In Lua it's not with an exclamation mark. And then you have two equal symbols to say equal. So these are all you can use in here, and they're very powerful to use. For example, if x is less than 5 and x is more or equal to 2, so we're checking if x is more or the number 2. So 2, 3, and up. And this is if x is less than 5. This does not mean including 5. If x is 5, this will be false because this only checks if x is less than 5. If you say less or equal to, then if x is 5, this will be true. So take note. Then here we can say x is between 4 and 2, both included. So this will see if x is less or equal to 4 or less than 5. This will check if x is more or equal to 2, or in other words, more than 1. It doesn't matter which one you use, more than equal, or less than equal. It more depends on what you prefer. I prefer just doing more than or less than, but occasionally when I'm a bit more tired, I would usually go for more or equal and less or equal. And if we run this, it works. If I make x 5, then it doesn't work. But if I say less or equal to 5, which will now include 5, then it will run it. This AND here just says both of these should be true. So if this is true and this is false, it will not execute. So if I were to say true and false, then it won't execute. But if I say true and true, it will execute. Or we'll do the opposite. Or we'll see if one of these are true. If one of them are true, it will run. So it will run. It won't run. Or it will run, my bad. And if both of them are false, it won't run. There we go. And in a not, we'll just basically invert something. So something that is not false is true. So it's kind of like speaking. If something is not false, it is true. If it's not true, it is false. So not false or false. And this will make this one true. And here again, brackets becomes an important part here. For example, if we were to do this, then it will say if not, and then whatever comes from this. False or false, this will be false. So if not, false. If true, then. So take note, brackets do play a role here. If I also make this one true, then it won't work. If I were to remove these brackets, then it won't work either, because true is now false. If I were to make this true, it will work. But if I wrap these in brackets, it will not work, because true and true, or true or true, will return true. And this will result in a true here, so if not true. Brackets can make everything a bit more complex, but also make what you can do a lot cooler. So let me show you an example of where an if statement could be useful. Let's say local age is equal to 15. So this person is 15. If age is more or equal to 18, then let's say they want to go into a bar. So we say print, you may enter. They may enter the bar if they're 18 years or older. And here, if this works, it will run. They're not 18 or older, so if we say 20, then you may enter. Now, what if we want to give them something else? For example, if they're, let's say 17, we want to tell them to scram. They are not welcome here. So print, you are not welcome, be gone. But you might already notice what will happen here. If I run it, we'll get both. We could go if, and then age is less than 18, and then throw this in there. This is perfectly fine. So now we have two if statements, and it will work. If we go here and say 17, then you are not welcome, be gone. But there's a cleaner way to do this. We can go else. Else is when this here does not execute. So when this is false. Now we can just move this up there. And there we go. We run it. You're not welcome. Be gone. Maybe change this to 18. then we'll run the top one. Let's say it's this bar is near a children's tourist attraction. So kids that are under the age of 12 might want to go to that attraction. So we could go here and say, else if age is less than 13, so everyone that is not a teenager yet, print the water slides are down the road. Cool. So now we're checking if the user's age that's trying to enter is more or equal to 18, they're allowed to enter the bar. If their age is under 13, we tell them that the water slides are down the road. Otherwise, they are not welcome and they should be gone, because then we know they're teens and they're trying to sneak in to get a quick drink. Run this, you may not enter, or you may enter. If we change this to 17, then they're not welcome. If we change this to 10, then the water slides are down the road. We can of course do more. For example, local birthday is equal to false. Now let's say it's their birthday. We can go if birthday, then print you get a free drink on us. So now if it's their birthday, they'll get a free drink. So you can use an if statement within another if statement. If we run this, let's just maybe make this 18. We'll get you may enter. If we make their birthday true, then you get a free drink on us. And there's a ton of things you can do more with if statements, but most of these you can just get by trial and error and by practicing what we've just learned. And last but not least, we can also do something like this. Local name, and let's say if local age here is more than 18. So if age is more than 18. And Mike or Jeff. So if the age is more than 18, then their name will be Mike. Otherwise Jeff. And we can imprint name. This is a cool one-liner where everything can be done in one line. So now we get Mike because their age is more than 18. If we change this to 15, then we'll get Jeff. So in this one line, you can set a variable using an if statement. You can of course also set a variable in a normal if statement. So true, and then name is equal to Luke. This right here is also valid, so print name. So this will also work. However, this is in one line, so it might be more comfortable. But if you prefer writing it out like this, then that's perfectly fine as well. However, take note, if you were to say local name here, it will recreate this name variable. And it will be scoped between this. So it will be scoped here. Meaning we can't use this name here. So if we were to print out name here, we'll get Jeff. If we remove this local, then it will try and access this name here. And we get Luke. So take note, when you declare a variable, you're using local. So local, and this will declare a new variable. And it will locally scope it. So it's only allowed in its current scope. Loops is a way to repeat code so it continuously happens. So it continuously runs until you tell it to stop. In Lua, there are 3 common loops we can use. The most common would probably be the for loop. And this is basically for a number until a number run the code. So for I, and this is just declaring a variable in this scope. If for I becomes 1, so we're starting at 1. Up until 10, so we're going up until the number 10. And then we can just say then, or not then, but do. And here we can say print I. This will count from 1 to 10 and print it out. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. From 1 to 10, it will just loop and loop and loop and change this I variable here. You can say how many steps it should take. For example, 1 is by default, so it takes 1 step. 1, 2, 3, up until 10. You can say 2, and now we'll take 2 steps. There we go. You can even make it go into the negative value, so -2. But this here would cause an infinite loop, so we'll have to go 10 to 1. So it's going to flip the 2. So I is going to start at 10 until it reaches 1 or less, and then it will stop. Now, as you can see, it goes downwards because we said -2. Cool. So that's a basic for loop. You also have a while loop. So while something is true, we want to do something else. This here is called an infinite loop. Since true here never becomes false, so if I say print Mike, it will forever print out the word Mike until I quit the program with Control-C. So this will infinitely loop until either the program crashes or your PC does. You can use break to break out of a loop, so bloop, it only goes once. Here we could do something like local count is equal to 0. And then if the count is more than 10, then we can break. And of course here at the top we can say count is equal to itself, count plus 1. Cool. So now we will break out of the loop without having to make this here false. So now we can say that, and I will print out Mike 10 times. Cool. You could also do this. Put that there. While count, and instead of more than 10, we can say less than 10. So while count is less than the number 10, run this loop. Now if we run it, until count is at least 10, it will run this code. Alright, and then last but not least is the repeat loop. So one thing I want to show you is, let's say count is equal to 10. If we do this, the while loop will never run because this here is never true. The repeat loops runs at least once. It's a while loop, but it runs at least once. So repeat until, and we can just take this right here, put it here, and then take this and put it here. It's the same as a while loop, but it will run at least once. In other languages, this would be called a do while. And my bad, it goes up until, so we should say up until count is more than 10. Or in this case, let's say 5, just to show you. So until this is true. So it will repeat this until this is true. So unlike with a while loop, it will not be while true, this will be while false. If we run it, we'll get Mike at least once. So it will run at least once before it quits. User input is relatively easy. Let's say we go here and say print, what is your name? And then the user can input something. So we can say local ANS for answer, but you can call this variable whatever you want. And we can say io.read. And this will get input from the user and then store it inside of this variable. Then here we can print ANS. We can maybe go name colon, and there we go. If we were to run this Lua file, what is your name? I will say Mike, and there we go, name Mike. Another cool thing you might be interested in knowing is how to get input on the same line as your output. Because sometimes you don't want an output and then an input on the next line. It just kind of looks ugly and sometimes is confusing. To get input on the same line, instead of print, you can use io.write. This is the same as print, but it does not have a new line at the end. So here we can say, enter your name, and it will enter, and it will ask for the input on the same line as this output. Now here we can say Nick, and the name is Nick. And of course then you can do things such as if answer is equal to Nick, and then you can like give special outputs depending on what the user inputs. But I think we all already know that. So if you're coming from another programming language, tables are usually considered lists, arrays, sets, dictionaries, objects, records, queues. A bunch of these things can all fit into the idea of a table. A table can be all of these. If you have no idea what I just said, then you don't have to worry about that. So let's create our first table. I'm going to say local tbl, and if I at any point say list or array, just know I'm referring to a table. And this table will be used with these right here, so these brackets. Anything that goes in here is part of the table. This can contain any types and any amount of items. So this, and we can put a 2 and a 9.9 and a true. All of these, they are allowed. Booleans, numbers, strings, even other tables. So we can go here and say, okay, cool. This is all allowed. If we were to try and print out table, then take note that you might not get what you expect. Usually when you print out something like this, you expect to receive that back. But in this case, we will receive a memory address. But if you want to get the items inside of a table, you could use a for loop. So for I is, or that's all caps, for I is equal to 1 to hashtag TBL do. And hashtag is just a short version of number of items in this table. Like if you have a string or a piece of text and you do this hashtag with it, as you might remember, we receive the length of that string. The same concept exists for tables. And in here we can say table and then pass in I. If we do this, we'll get each item inside of the table. A this, 2, 9.9, true, and then another table, because this is a table here. So we'll have to for through that as well if we want to see the items in it. Now you might be wondering, how does this work? How can we do that? Well, if we go look here and we say print TBL at index 1, and this is called an index, and we run it, we'll get this. This right here is the first index. So if we were to go like this, we'll get index 1, which is this, index 2, index 3, index 4, index 5. And the more you add, of course, the more indexes there will be. So it starts from 1, and currently it has up until 5. If we go 5, then we'll get a table. If we say 5, 1, then we'll get okay, because here we're saying, okay, go to this 5th index here. And then in this 5th index, return the item at index 1 of it. So this would be 1. And this here would be index 2 of this table. We'll cover this a little bit more in a second, but this is just as an example. If I were to say 4 will get true. If I were to give a value that doesn't exist, like 9, we'll get nil. Nil just means empty, doesn't exist, nothing. Now usually, you'd actually create a table with the same data types. It's not too often that you'll see tables using different data types, unless you use it in a sense of an object, which we'll get to a little bit later. But when you just use it as an array, so a way to store multiple values inside of one variable, then you'll usually just use the same data type, so just numbers or just text. For example, let's say we have local x. Well, let's actually start at A, B, C, D, E, and you can imagine this going up until Z. And we could say we're storing 1, 2, 3, 4, 5. Now you might already be seeing how this is not really very practical, because it's fine to have a bunch of variables lying around that are storing their own values, but all of these values are related in some way, but they're stored in their own variables, which there's nothing wrong with this method. It's just there's a more comfortable way to do this, where we could go local alpha nums, and this will get all of the alphabetical numbers, which we would have usually done by doing A, and then A is equal to 1, B is equal to 2, C, and whatnot. But here we can create a table with 1, 2, 3, 4, 5. This is the same, but instead of having to use a specific variable, so print A, we have already grouped them together, and we can just say print alpha nums at index 1. This will give us the same value because A and 1 is the same thing. If you wanted, you could also put variables in here. You're not limited to just values, because variables on the end of the day are just values. So this will still work perfectly fine. If I say index 2 where B lies, then we get 2. If I were to remove this, then this will no longer work. So we'll get nil because B has never been defined. Now let's go here and say we have 1, 3, 5, 7, 9. And we can just call this local nums. Then let's say we want to add another value into this table here. Let me just also for each item. So 1 to the amount of nums. And here we can print nums at index I. If we run this, we'll get 1, 3, 5, 7, 9. Now let's say I want to add one thing in here before we run that. We can say table.insert, and this will insert an item into an table. So first we specify the table, in this case nums. Then you can either specify what you want to put in here or where you want to put it in. If you don't specify where, it's just going to put it at the end. So if I say 19 here and I stop here, it will insert 19 at the end. So here, if we run it, we get 19. But if I instead in the middle put 2, then it will insert 19 at position 2 here. So if I run this, we'll get 119 free. So this here allows you to get a position you want to put it in. Without it, it will just append it to the end of this table. You can of course also remove, and here you pass in the position, not the value, but the position. So if I say 1, 1 will no longer exist. If I say 4, 4 will no longer exist, because 4 was 7. There's also a nice special way you can loop through these tables, which is other than this normal for loop. Instead of using hashtag nums, you can use pairs. So here you go, pairs, and you pass in nums. Now you can get K and V. So for K and in V in pairs num, if we were to print out K, we'll get these values. So 1 to 5. This would be the index. So in this case, we could say index, and v would be value. So index, we can actually just do index and then value, and it will do work the same. So index 1 has 1, index 2 has 3, index 3 has 5. So this is a nice way you can for through a table in case you don't want to for through the numbers. Maybe you want the index as well as the value. Well, you can get both, but in pairs it's split. It's up to you which you prefer doing. Now let's talk about multi-dimensional tables, also known as multi-dimensional arrays. This is a table inside of another table. For example, here we can create another table, 1, 8, 3. Okay, let's create a few more. This can have 4, this can have 7, this can have 5, this can have 2, and then last we can have 6 and 9. Now if we were to print out nums, we'll get our table location in the RAM. If we were to print out num at index 1, we'll get the location of the table in that table. If we specify another value in here, then we'll get the first index of the first item here. If we say 2, we'll get 8. If we change this here to 2, then we'll get 2 because this is index 1 of the first table. This is index 2 of the first table, and this is index 3. So this would be the first table. Now inside of it, you have index 1 of the first table in the first table, or the first item in the first table, and then index 2 and index 3, and then index 3, 2, 1, and then 1, 2, 3. If you were to pass in something like hashtag nums, you'll get the amount of tables in this first table. So if I were to copy this a few times, we'll get 5. But if you specify an index here, for example 1, you'll get the length of the items here, 3. So this is 3, this is 5. We can add more here, so now it will have a different length. If you want to display all of the values inside of this, then you can also use a for loop. So here you can go for I becomes 1 to the num, or to the amount of tables in nums, and then for this time j, because we can't redeclare I, that won't be a good idea. For j becomes 1 to the amount of items inside of I, because I is a table, so we'll get the amount of items in I. So this would be I, and each item inside of I would be, or each value here would be j. So this is I, this is j. So here we could print nums, so nums, and then at index I, and index I will give us the table. So we specify the next index, which would be j. Now, and my bad, this here is a number. It's not a table. We have to say nums at index I. My bad, because I is a number. Just like j is a number, it's not the actual value. If we run this, as you can see, we get 183, which is the first items. And then we get 426, which is the second. And then 759, which is the last. So if you're having a bit of trouble with this, just note nums at index, and in the first index, which we can call x, would be the first item, or the second item, whatever x is here. If you add another one here, it will try and access the item inside of this item. So x, which is this, and we'll try to access y inside of it. So let's say 8. If you have a table inside a table inside a table, you could also add your z. So if I were to have a table here as well, and we can go 2, 4, 5, and we can have a few more, then I could do this, where I have 3 attached to each other to access each item in a table. But take note, tables can become incredibly complex, incredibly fast. So I always recommend to, when you use a table, not add too many items into the table. As in, don't add 3 or 4 tables inside of one table here. So this right here is already very complex. If I were to go here and I were to add another table here, so now I were to add another table of more values, then it will be more complex, because now it's no longer x, y, and z. It has started to go into complexity where x should now be shifted to something else. I'm just going to move this here to the front. And we can just put an A here for now. So I would say always follow the X, Y, Z rule. This is the complexity rule where you don't have more than 3 tables inside of one another. If it becomes more than 3, it becomes very difficult to not only manage, but to work with. So I'd always say try and stick with 3 or less tables. So here there are 3 tables. If you were to remove this like that, then there are 3 tables. So this table here, and this table here. So unless you have specifically named items like an object, which we'll be getting to, then never go past the XYZ complexity in a table. Usually just try and keep it as simple as possible. Then you also have 1, 2, 3, if we were to go like that. Now let's say we want to convert this into a piece of text. Well, we can go print table.concat, and this will basically join a table of all of its elements depending on the separator you give it. For example, if we pass in nums2 or nums and we pass in a space, then it will print it out with just spaces between each item. This here is now a string. Take note, this is a piece of text. And you can replace this with anything, so it can be a semicolon, another number, so dash 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 will work, and so on. And then finally, for named items inside of tables, and we'll get more deeper into this, but for named items, you can go local tbl, and here we can do something like name is equal to Mike, and then age is equal to 12. Now if we go tbl, that's index 1, and we print that, then we get nil. But if we go tbl and then name, we get Mike. So this is a named table. Some people also see it as a dictionary or an object. And yeah, those are the basics of tables. Now, a function is a snippet of code that you can execute as if it was a variable. For example, let's go here and say local function say hello, and this will just print hello. Now we can call this by going say hello and then adding 2 brackets at the end, and this will call this function here, which will print hello. So if we run this, we get hello. And of course we can put as many things in here as we want. As you can see, if we were to go print 1 and then 2 as well, and we were to do this, so print it 2 times by calling hello, then we'll get hello 1 2 hello 1 2. So every time you call this function here, it will execute the code inside of it. And you can call it as many times as you want. This is a great way to stop yourself from having to copy, paste, copy, paste, copy, paste. This is a very common practice where programmers will try and reduce the amount of times they have to copy paste a line of code or even a block of code. Variables can save you a line of code. A function can save you a block of code. Now let's say we wanted to make this hello function a bit more complex. So instead of just saying hello, we want to pass in a name. For example, hello Jack. Well, this here isn't very useful because it will always print out the same name. So instead, what we can do is we can pass in an argument and we can call it name. So this is like a variable that gets passed into this function. Now instead of saying Jack, we can say dot dot name dot dot. There we go. Now if we go here and we say Luke, by passing it in here between these brackets, and this would be name, we'll get hello Luke. If we change this to Jack, we'll get hello Jack. Sometimes you want to give it a default value. So if you don't pass in a name, you want the name to be a default value. Well, to do that, we can say local name is equal to name or Jack. So what's happening here is we're declaring a new name variable. And then we're basically overwriting what this is going to be on the end of the day. So we're saying this name is equal to itself, or if there's nothing in here, if this is a false value such as nil, then make it Jack. So it will default to Jack. So if we have 3 here, the first has nothing inside of it, the second has Mike, and the third has Sally. Then if we run this, we get hello Jack, hello Mike, hello Sally. Without that there, if we did this, we'd get an error because you cannot concatenate a nil value, because this name here would be nil if we didn't pass in anything in here. Now let's go a bit more complex and do sum. And this will get the sum of 2 things. Let's say we get num1 and num2. Then here we can just return the value. But how does one return a value here? Because we could print out what it is, so print num1 and num1 plus num2. And we could call this sum 10. And just to show you, you could also go local x is equal to 20. You could also pass a variable in here, so x. So that will be 10 plus 20. If we run this, we get 30. But what if we want to work with the value that this returns, that this would give us? So we wanted to store local answer is equal to sum and then print the answer is and then ons. What if we wanted to do something like this? Well, we'll get a problem here because we cannot concatenate a nil value. This here is nil because sum just prints out this value here. To return a value, we can use return, and this will return this value. You could either do it like this, or you could go local result is equal to that and then return the result. Now anything here with return will be returned from this function, and nothing after this return will be executed, which we'll explore in a second. If we run this now, we get the answer is 30 because this here now returns this result, which can be either in its own variable or like that. But take note, we can go here and say print func start and then func end. You'll notice we get some red squiggly lines. End of file expected after return. That is because after return, we are not allowed to put anything there anymore, because after return, nothing will execute. So if we run this, it will just throw us an error, because nothing should be after return. Once you return, the function stops executing. But this doesn't limit you as much as you think it would. If we say, let's go here and say local val num1 plus num2. If val is more than 10, then return val. If val is less than 100, then return negative val. Otherwise, we could just return val times 2. So this is just an example where just because we have a return doesn't mean it will stop everything else from executing, because this return will only run if the value is more than 10. And this code here will never really work as expected, so let's make that equal to 10. There we go. So this will only execute if the value is equal to 10. This will only execute if the value is less than 100, but not equal to 10, because this will stop execution first. So if we say 1 plus 2, then that will give us negative 3, because it is less than 100, so it will give us this. If we say 8 plus 2, it will give us 10, because the value is 10. If we were to say here 101, so 101 plus 2, that will give us 206, because it's the value times 2. Let's first try to create a file. That is pretty simple, so let me just also open up my file viewer here so we can see if any files appear. io.output, and here we can pass in a file we want to create. So my file.txt. This will create a file, my file.txt. If I open the containing folder, you'll see there's a my file.txt now. If I were to delete it from here, you'll notice it also deletes it from here. This here is the same as this here. Anyhow, so if we create this file, then that will happen. But take note, it will empty the file if it already exists. So if I go and put some text here, let's actually have it here on the side of the screen, and I decide I want to execute this, as you can see, it empties the file. So you should take note here, it will create the file, but if it already exists, it will empty the file. Now this output can be used also with writing to a file. So io.write. And here you can put some text you want in the file. Hello world. And we just have to io.close whenever we use any of these, because you don't want the file to be open and then later on try to work with it again, or if other program tries to work with it but yours already has it open, it will cause issues. So you should always close the file after working with it. Now if we were to run this, we can actually show this here at the side again. We run it, we get hello world. If we run it again, we will get the same output, because this anyways rewrites this file. It will empty it if there's nothing inside of it, or even if there is something inside of it. Now that's the first way you can write to a file. Now the first way to read from a file, we go io.input this time. So instead of output, we are using input and then the file. So my file.txt. Then we can of course io.close. And here we can say local file data is equal to io.read, and then we can just say asterisk all. This will read everything inside of this file. And we can of course print file data. We run it, we get hello world. We can add some more like x2, x3, I am cool. If we save that and we run it here, we'll get hello world, x2, x3, I am cool. So we first take the file we want to read and say it's an input file because we want to take input from that file. Then we read it with the asterisk all, which means read everything inside of this file. And we can print the data that we read, and then we can close the file. Or we could close the file and then print the data, whichever you prefer. So that's the first way to read and write a file. Now the second method is what you'll most likely see being used. So let's first try and write to a file. That will be local, and we can say what variable we want to save this file in. So file io.open. The file name, so myfile.txt, and then what you want to do. So here we could specify all of these. So read, write, append, read and write, write and read, I think, append and everything else. Read byte, write byte, append byte, and so on and so forth. But we're mainly going to be focusing on these here. So first we'll have write. Now W just means write, so we'll write data to a file. So here we can then say if file is not equal to nil, so if the file we're trying to open exists, then, so if the file we're trying to open can be opened, then we want to go file, write, and we can just say hello there, and that will write to the file. And then of course file, close. Else, if we could not open this file, we can just print could not open the file. Now if we were to run this, we'll get hello there. If we were to delete this file and then run it, it will generate the file and enter hello there. So this method is usually the preferred method above io.output as well as io.input, because we'll learn how to read right now. Now there are multiple ways you can read from a file. One way you can do it is going file and then read, and here we can just specify asterisk all, and this will read everything. So if we go here and say x2, x3, goodbye, and we read it, of course we should maybe print out what we get, so print, then we get hello there, x2, x3, goodbye. You also have asterisk line, which will only read one line. So if we go here, hello there. If we then do it a few times, for each time we do this, it will read a new line. So hello there, x2, x3. So if you want to read line by line, this is a good way to go about it, by using this asterisk line. Otherwise, you can just go asterisk all, and that will read everything. And then last but not least, let's take a look on how to append it to a file. Now, when you write to a file, you will overwrite everything that's already inside of the file. So if I were to go here, W, and then say write, and change this to goodbye, then it will overwrite everything. And also doesn't help if you print it. But it will overwrite everything and add our goodbye. But what if we wanted to add something to the end of this file? Then we could use A, which means append. So then we can say appended text. If we run this, we'll get appended text. If you wanted to go to the next line, you could use a \n here, which means new line. Appended text 2. Now it's appended text 2 on the second line. So that's how to append. Now, the term module in Lua refers to a Lua file that returns a single table when it is called. So it returns a table or an array or an object, as some might understand it. So it's basically any file that's not this main file that returns something on the end of the day. And then you also have a package. A package is a collection of modules. So if I say I'm going to go and install a Lua package, that means I'm going to install a few modules that will allow me to make my coding in Lua easier. For example, the Luna CJSON package, because that's a package of modules I am going to use in my program to read JSON. Alright, so let's get an example in here. I'm going to create a new Lua file, call it custom.lua. You can call it whatever you want. Then here, I'm going to go and say mod is equal to a table. So I'm saying this is a table here. We can then go here and say function mod.sum, and here we could say x, y, and in return x plus y. So we're putting the sum as part of this mod here. You could also go sum is equal to function and then say x plus y. This is just as valid if you just say return, because these two mean the same thing if we were to put an x and y here. So this would be the same thing. And of course we can have our mod here with, let's maybe say hello. And in here we can maybe get a name. And then we could say print hello name. Now these are just very basic examples. You can put any function you want here. I'm just making very basic functions here as an example to show you. Then we return mod, because this mod will now be used outside of this file. So here in main.lua, we can now use this module. Local mod is equal to require, and then we pass in the name here. So custom.lua, or just custom, because it will automatically add the .lua when searching for it. This will import this module for us and store all of the things being exported inside of this right here, so that variable. We can then go print mod.sum 10.5 or mod.sayhello Mike. If we run now, we get 15 and hello Mike. All of them are made inside of this module here. This is a way to keep one file from going like to 10,000 lines of code, because you could split it up, so one file could have 1,000, another could have 2,000, another could have 500, and it could just make the process of reading this main file much easier, since we're importing the stuff we need from outside. But that's the basics of modules. It's just another file that's returning a table. And this table contains a bunch of functions or variables that we can use here once we import it with require. What exactly is OOP? OOP is object-oriented programming. It is when you think of your code as objects. For example, you have a car, that's an object. A car could have wheels. A car could drive. A car could do this. You have a pet. You could have a cat pet. You could be able to feed your pet. You could be able to give your pet a name, because a pet is just an object. You could have a cup. A cup is just an object that you could fill with water. That's the whole idea behind OOP. Everything in your code is an object. Some people love OOP, some people hate it. I personally love OOP when doing game development, but prefer using procedural programming, basically what we've been doing up until now, with normal programs. Now in Lua, there are multiple ways to do OOP. There's not just one, not just two, there's more. I'm going to show you one way to do it, but if you don't like this method, you could go and search for a different method that you might like more. There's one that uses meta tables, but I find that method to be very confusing to understand and a bit difficult to use. So instead, I like to use functions and simulate OOP with them. And I'll show you an example. Let's create a object, local function pet. This is your pet. Now your pet could be a dog or a cat, but this is a pet. It is what you use when you go, Charlie, come here, I have a treat for you. You're calling your pet. And we will return a table, because a table is the best way to get an object. If you maybe come from Python or from JavaScript, then dictionaries or objects, it would be the same concept. And here we could do something like name is equal to Charlie. Then here we could go and say local pet, or even cat is equal to pet. And then we could print cat.name. Anything inside of this return is public and can be used with this object. Now if we were to run this, we get Charlie, because this is just a table. But we disguise it as a function, which generates an object for us. This is nice because now I could have two pets, one that's a dog. And now I could go dog.name. Both of them will be Charlie, so this pet is a bit flawed. Let's allow us to change the name. So name. We'd say name is equal to name or Charlie. So if they don't enter a name, it will default to Charlie. Here we could say Jack. So my pet is called Jack. Now my cat is Charlie, my dog is Jack. On the end of the day, these are just a bunch of tables. But we can create or generate tables for us by calling functions. So that's pretty neat. Now take note, if something is not in this return, it won't be returned for us to use. So if I go age is equal to 10, I cannot use this age here. I could use it here. So I could go days alive is equal to age times 365. There we go. Now here, I can't go cat age and then dog days alive. Only dog will return a value because age is not returned. Only the things in returned is returned. Also, we can just go local here. So if I were to run this, we'll get nil and 3650. That is because age is not returned, so we don't know what it is. This can be seen as a private property of your object. So something you can use only in your object and it cannot be used outside of it. And this here could be seen as a public property that can be used and called outside of this object. You then also have two types of functions. You have the speak, and this function is just a normal function. And we can just say print, and let's just go meow. Even if it's a dog, let's just say it meows. Then you also have another function, which we could call feed. So if you want to feed this pet, that can be a function that takes in self, and we'll discuss it in a second. And for now, right now, we don't have to do anything here. We can just say print. Okay, so here we have a basic class with two types of functions. This first function here can be called with this dot syntax, so speak. And it doesn't return anything, so we don't have to print it. But you take note, this second function, so we go feed here, will not work because it takes in self. And self is what you use to specify this object. This right here. This is the self. It is this table. Self is referring to this table. It's referring to itself. But this won't work. So if we run this, we'll get meow and eating. But we go self.name and we try and run it now, we'll get an error because self is a nil value. So once we want to use self here, which allows us to reference anything inside of this table, we cannot use this dot syntax anymore. We have to use a colon. colon basically passes dog into itself in a sense. So this first value here is going to be this here. So if we go here and we run this, we get eating and then Jack. So these are the two functions you'll usually get. I usually just say make all of them include self, even if you're not using self, because then all of your functions will require a colon and you'll never have to wonder, is this function not working because it needs a dot or a colon? It will always need a colon. So I always say include self even if you're not using self. And itself here can be used to access any value inside of this right here. So I can go self speak. And now we can speak. We run this, we get meow, eating, Jack, and then meow. That is the basics of these types of functions. But usually just stick with self and you won't have to memorize what the other does. Now let's say you want a type of pet that isn't in its own a pet. Or it is a pet object, but it's more specific than that. This is called inheritance. So let's say I want another type of object. So local function dog, right? Dog takes a name. But now we go return. And we're like, okay, I want all of these inside of dog as well. So we copy, we paste. We now have all of the same things. But now we want to add a few new things. We want to add breed, which is equal to Doberman. And we have loyalty because dogs can be very loyal. And we'll make that equal to 0. So now we have a dog that has all the same items as this pet object here. And we can go local Doberman is equal to dog Jesse. And now we can say Doberman dot breed. And now we can get the breed of this Doberman. And let's, while we're at it, get Doberman dot name. If we now run this, we'll get Jesse, which is a Doberman. Cool. But now we decide here inside of our pet, we want to add another item. We want to add status. And status will be something like hungry. Now, since we want dog to have everything pet has, we now have to remember, and this could be like a ton of objects that could have the same types of items in pet. But now we have to remember, we have to copy this and we have to go paste it here as well. We have to remember that. And a lot of times you'll have 5 or even more objects that will be inheriting from this object. So it will have all of the same items. So you will have to remember all of the objects that's using this object so you can go and copy paste all of these here. This isn't the way to go. Instead, you should use inheritance. Inheritance is when you inherit all of the different types of properties in one object and you use it in another. So here we could say local dog is equal to pet, and we pass in this name that gets passed into dog. Cool. Now we return dog. And then instead of creating this object here, we can now just append to this already existing one. So dog dot breed, and we can make that equal to this right here. Dog, and then dot loyalty, like that. And then we can remove this part here. And now we have successfully inherited all of the properties that's being returned here. So we get name, we get status, we get speak, and we get feed. We get all of these here. And now we add 2 more properties onto this property we have, or onto this table we get from this, and return that. Now we'll have both the name and the breed, even though we didn't copy paste any of these here. If we run this, we'll get the same output. And once we change anything here, so anything here, for example, we can add points for some reason and make that equal to 10. I can now, in my dog, I can access points, even though I didn't actually copy paste that data here. We can now also go breed, and we could rather pass in the breed or Doberman. So now we could actually go here and say poodle. So now we get a poodle instead. We run this, we get JC Poodle. We can overwrite functions that already exist here as well. For here we say meow. We could go dog.speak, and speak is a function that takes in self, and then instead of saying meow, it says woof. So now when we go poodle speak, it will say woof. This is the power of inheritance. So we can have a bunch of objects that's inheriting from this object. So now we can maybe go here and we can create a cat, which has the same types, but this time it maybe doesn't have a breed because I don't know any cat breeds. It doesn't have loyalty, doesn't have speak, and here say cat, and we can go here and say lazy, and that could be cat.lazy is equal to true. So if the cat is lazy or not. Now this cat has all of the items inside of pet and one more that's lazy. And of course, if you wanted to, you could make cat inherit everything from dog. You just of course have to pass in the breed, which I don't know, IDK. And now cat has all of the items inside of dog and the pet, because dog has everything inside of pet. So cat now has everything inside of pet and dog, because cat is inheriting from dog here. And this is the basics of OOP. You might not quite understand everything here yet, but once we get to the game development section of this course, then you'll quickly start to understand the power of object-oriented programming and how everything here connects with one another. Thank you all for watching. I hope you all enjoyed, and I will see you all again in the next Lua tutorial.